Okay, we're going to be finding the limit of a function. Our function here is f of x equals x squared minus 4 over x minus 2. And here's the graph of the function. It's just a line with a hole at x equals 2. This means that f of x is not defined at x equals 2. And this is because if you plug in 2, you get f of 2 equals 2 squared minus 4 over 2 minus 2, which gives us here a 2 in the denominator, 0 in the denominator. And with the 0 in the denominator, it means that our ratio here is undefined. So f of 2 is undefined. So now, even though we have this point of discontinuity, or a point that is undefined, we can still find the limit. So that is the limit as x approaches 2 of f of x, which is x squared minus 4 over x minus 2. So the way we can do this is by finding the right-hand limit and by finding the left-hand limit. So this is the right-hand limit, the limit as x approaches 2 from the right. This plus sign means we approach 2 from the right of our function. And we also need to find our left-hand limit, which is the limit as we approach 2, as x approaches 2 from the left, of x squared minus 4 over x minus 2. So we can find these separately. So let's start with the right-hand limit. So if we choose some number to the right of 2, of x equals 2, say here, we can find the corresponding f of x value. So here's the value on f of x for our chosen x. So as we approach 2, we can see that our f of x, our function, starts to decrease. And as we do that, as we approach 2, our function approaches, it looks to be 4. So as the limit as x approaches 2 from the right is 4. So we can do the same thing for the left-hand limit. We choose a number x to the right of 2, doesn't matter where, we'll say on the other side of the y-axis. Choose an x value here, corresponds to this f of x value here. Now, as we approach 2 from the left, we can see that our function increases and approaches our hole there. So we can keep approaching 2 from the left, and as we do that, our function approaches again 4. So now what we have just shown is that the limit as you approach 2 from the right is equal to the limit as you approach 2 from the left. They are both 4. So that means that our limit as we approach 2 exists for this function, and it is equal to 4. It is just equal to the left-hand limit and the right-hand limit, which again is 4. So it's important to note that this exists and is equal to 4 even though our function is not continuous here. Or rather, at x equals 2, f of x is undefined. So, and that is okay. So this is one way to find the limit. We can use the graph of the function. Another way would be to do this algebraically. So the limit as x approaches 2 of x squared minus 4 over x minus 2 is just equal to the limit as x approaches 2 of x squared minus 4, which we'll just factor now. X squared minus 4 is x minus 2 times x plus 2. So we factor the top and leave the bottom the same. So what we notice here now is that x minus 2 and the top cancels with x minus 2 in the denominator. So this is now equal to the limit as x approaches 2 of x plus 2. And now we have just a linear function, x plus 2. So the limit as x approaches 2 of this linear function is the same as just plugging in 2 now into x. So this is 2 plus 2, which is equal to 4. So again, we found in a different way the limit as x approaches 2 is equal to 4. So we can write that here. The limit as x approaches 2 of x squared minus 4 over x minus 2 is equal to 4. So we got the same answer. Again, f of x is not defined at 2. That's okay. And now we had to simplify. The reason we could not plug in 2 from the start is because if we did, we would have that 2 squared minus 4 over 2 minus 2 would be 4 minus 4 over 0. And again, this would be undefined, this entire fraction, undefined. So we had to do some simplification, but we were able to get the same answer. The limit as x approaches 2 of x squared minus 4 over x minus 2 is equal to 4. If you'd like to see more examples or more explanation, please check out the next video.